Welcome to 24 Hours of Past Summit Preview. We're excited you could join us today for Hope Foley's session, Spatial Data, Looking Outside the Map. This 24 Hours of Past event consists of 24 consecutive live webcasts. Sessions will be recorded and posted online soon after the event. My name is Andrea Allred, and I'm a database administrator and have worked with SQL Server for 13 years. Come find me at Past Summit 2014 in a princess dress. I have a few quick introduction slides before I hand over the reins to Hope. She will speak for 40 to 45 minutes, and then we'll move on to Q&A, where you can ask any questions you may have. Hey, Hope, can you switch to the next slide?
Oh, sorry, yeah.
If you're having any issues, type your issue into the question pane, and someone will assist you. To maximize your screen, use the Zoom button located at the top of the presentation window. Feel free to enter your question in the Q&A field at any time. The questions pane is located on the right side of your screen. Once we get to the Q&A portion of the session, I'll read off your question to the speaker. Please note there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It will show up on your screen. Next slide. I'd like to take a moment to thank our event partners. The staging of 24 Hours of Past would not be possible without their support and dedication. They are the reason this event is available free of charge. Thank you to our presenting sponsors, Microsoft and Dell Software. Next slide. This 24 Hours of Past is a preview of Past Summit 2014, the largest conference for SQL Server and BI professionals with over 5,000 attendees representing 2,000 companies from 52 countries. Summit is a time to share, connect, and learn with your peers and industry partners. Past Summit is not only a week of intensive learning and knowledge sharing that will offer strategic insights, it's a time to network and rub shoulders with industry experts. Taking place in Seattle, Washington from November 4th through the 7th, Past Summit will feature over 190 world-class sessions across 5 topic tracks. These 24 Hours of Past sessions provide a mere glimpse of what you can expect from Past Summit. Find out more at www.pastsummit.com, and if you register by September 26th using discount code 24HOP14, you'll get $200 off the registration fee. And now, please allow me to present the speaker of the hour, Hope Foley.
Okay, so it's on to me now. Hi, my name is Hope Foley. I want to thank Andrea for moderating today. I want to thank the PASS organization for allowing me to present today. This is a huge honor to be a part of the 24 Hours of PASS, and thank you again to the sponsors. So that's me. I'm a SQL Server MVP. I've been a DBA for many years now, and I've been a consultant, so it's allowed me the opportunity to have quite a bit of variety in the things I've done with SQL Server. So, and I also, let's see here, I will go ahead. So what we're going to be talking about today is spatial data. And I have, this is a subject that has kind of crawled under my skin and won't let loose. I really enjoy talking about this. It's one of my favorite topics to discuss. And it was kind of a topic that came to me by accident. I filled in for a colleague back in 2008 when this first came out, in SQL Server 2008 when spatial data first came out. He couldn't make a commitment giving a presentation on it. I didn't know anything about it, and it was when I was reading about it, it was a topic that it didn't make sense to me, but when I started digging into it a bit more, I really had kind of an aha moment with it, and I'm hoping to do the same for you guys today, is to help understand the power of what spatial data can do. So thank you all for coming. Here's another me spiel slide about this, but I've already talked enough about myself. I will point out, though, just because beer data has a way of sneaking itself into a lot of my demos, because the last point, I'm a kind of an admitted beer snob. I'm big on the microbrews and try and drink local. So if there's an overabundance of beer data that works its way into my demos, that's the reason why. So enough about me. So like I said, we're going to talk about spatial data, and if there are folks out there that are doing something with spatial data, I would love, I'm going to have my, my contact information at the end of the presentation. I would love to hear what you're doing with it. Just, it's a fascinating topic to me, and the sky is the limit with what you can do with it. So if you are using it, let me know. I'd be interested to hear what you're doing with it. Most, however, are not. It's kind of the, like an abstract. It's kind of not the redheaded stepchild of features, but it's not very heavily used. So we're definitely going to go over kind of an overview of what spatial data is, and how you some of the different things you can do with it. And we'll be doing kind of a real world demo of some spatial data. So I'm a very learn by doing kind of a gal, and so we'll definitely be, I'm going to try and get through the slides as fast as I can and just play with spatial data. So, and then at the end we'll have wrap up and questions. I've crammed this really full, so if we run a little bit over, I will definitely blog. They're going to collect the questions. If we don't have time to get through all the questions, I will answer questions on Twitter, or do blog posts to answer any questions you guys have that we might not be able to get to. So well, let's go. So this here, so what the heck is spatial data? This is a big, large, fluffy definition of what spatial data is. This is my definition of what it is. Very, very simply, it's laying out of shapes on a map. Excuse me. Note that map is in quotation marks. The reason for that is, so when you think of map, this is probably an example of something that might come to mind. And this is pulling spatial data. This is from a previous incarnation of a spatial data session I've given, and I've collected microbrewery data and plotted that out on the map. So this is pulling spatial data. I'm in Indianapolis, so that's the reason why I was focusing on Indiana. So like I said, beer sneaks its way into all my demos pretty much. This here is also another example of the same. This is actually the same data that we just saw, but a different view of it. So this here, Microsoft has come out with a lot of power, fill in the blank tools lately. Power Map, Power View have some really nice mapping capabilities. This here is Power Map, a view of Power Map, a heat map in Power Map. See, I'm getting my powers mixed up. But I will mention that all of those power tools do not yet support spatial data, so I had to step back on this particular view of that same data using the latitude and longitude. So, but again, another typical example that you probably think of when you think of map. This is another example of map, though. What this is a little snippet view of Management Studio that's pulling back some spatial data as well. And this is where I want to focus, because this is where I feel that not many people see this angle of the mapping capabilities of spatial data within SQL Server. So so what this is a floor plan. These are hotel rooms for a hotel in New York. So this is, and so floor plans can also be maps and laying out of spatial data. And this here is another example of a floor plan. When we get to the main demo, this is where I want to focus, because I don't feel many people have seen this, and I want to make sure to kind of show that angle of mapping capabilities as well. So okay, now that we've seen some examples to get you kind of thinking that direction, spatial data, there are two different types of spatial data. One is geometry and one is geography. The geometry data type is when you're going to have flat maps. If you don't care about the curvature of the Earth, then you're going to, you would be fine to choose the geometry data type of spatial data. If you do need to account for the curvature of the Earth, then you would use the geography. When I first started hearing that, oh, why is that important? So here's an example I like to use of why that's important. So on the left here, you see a flat map, which goes along with the geometry data type of spatial data. Over on the right is the round Earth or geography map. So if we had a flight, so for example, this path is a flight from the West Coast over to Europe. That's how it would look on a flat map. But if you take into account the curvature of the Earth, your flight path is much different. That's the reason it will be important to, so a nice visual of why it's important when you're choosing those. Like I said, we're going to be doing some stuff with floor plans, so the geometry is fine for that. In a typical building, you don't need to account for the curvature of the Earth. But if you do, if you're storing like latitude and longitude, you're definitely going to want to use the geography data type. So, okay. Now, I hate to break it to some. I used to be one of those people who are like, oh, I'm never going to use this math ever again. We are going to use some math that you probably haven't used, and you may have said that, oh, I'm never going to use that again. So in spatial data, it uses grids. So I've plotted out a couple grid points on here like you would normally back in school when they would pass out the grid paper and tell you to do that. So what you do is you go over on the x-axis and you go up on the y-axis. Now if you see over on the right, I have a couple different shapes, how they would be represented in SQL Server spatial data. So the point you can see is dictated, the x and the y-axis are split by a space as opposed to a comma like you would use in your old school grammar or in your old school schooling of plotting out grids. The line string, you do use commas, but you can see in this line string example, this particular line string, when you have multiple points, then you use a comma when you're dealing with the SQL Server spatial data type. So, very cool. So now that we've got that, if you remember from my definition, shapes, I said the laying out of shapes on the map. There are many shapes inside of SQL Server spatial data type that you can have. I mentioned points, line strings, polygons. Polygons are used a lot, and we're going to see some examples of these. It sounds complicated, but it's really just a closed two-dimensional shape. There also, in 2012, in SQL Server 2012, there was a really nice new feature added to allow you to have curves. Before that, it was just straight lines. You could have a curve in that you could have a lot of small straight lines that would give the illusion of a curve. But until 2012, there wasn't the ability to have curved lines or circular strings until 2012. So that was a nice new feature. So on the right, there are some of the newer features in 2012. Like I mentioned with the points doing, the X and the Y, the second point in a circular string is basically giving you the curve point, and we'll see those. I know I'm going to get through these slides real quick, so we can get out and play with this. So shapes. I know when I first started hearing about shapes, reading about putting shapes in a database, it didn't make a lot of sense. It's like Betty in accounting has never asked me to put any shapes in it, store any shapes in a database, but we'll see why you would want to do that in just a bit. Methods, there are many. This is a very small list. There are tons of different methods or functions that you can use with spatial data that help make complex calculations very simple. So there's just a few, and now we're done with slides, so let's get out and play with this. So I'm going to bring up Management Studio here. So I'm just in Management Studio. I'm going to run this first query to show a simple example of shapes. Something I want to mention too is when you can see this is pulling back this big, large binary, super large binary gobbledygook. What this is there are 3 different formats that you can view spatial data. This is how it's stored in SQL Server and is called the well-known binary. But if you see up here, this right here is an example of the well-known text. Most of the time when you're dealing with spatial data, you're going to be dealing with the well-known text. For those folks out there, there also is GML, which is the spatial data flavor of XML. So if you're one of those types that really enjoys XML, you know, God bless you. There is also a version of XML that's available within spatial data as well. So we're in Management Studio. I run the query. You can see by default when you do a query that contains spatial data, it brings up this Spatial Results tab. So brace yourselves. I am not the best artist in the world, so this first shape is not going to knock your socks off. So this is a polygon. And you can see here it's plotting these different points. So we go 2, 2, 2, 6 on up. So not super snazzy. And then this next one you can see is a line string. Now it's not often that you get to use your imagination in a SQL Server technical session, but let's use our imaginations for a second. And let's say this particular shape actually is an area impacted by a disaster. So, for example, an oil spill. So this particular shape could be anything in the world that we want it to be. But for imagination, let's just say this is an oil spill and the area impacted by an oil spill. And pretend that this line here is a river. I'm not the best artist, so we'll have to use our imaginations a lot. So just keep that in mind, that example in mind for just a minute. I want to show you too some examples where you don't have to use your imagination as much. So I'm going to run this query here. It's pulling back data. And if you take a look at this is a shape. These are shapes that you don't necessarily have to use your imagination as much. Like I said, I'm from Indiana, so I picked Indiana. But this is giving each of these different colors. So if you can see, if I hover over it, this is giving me back the other results from my query. And each one of these. So let's run this query as well. You can see it's the same information being returned. But I'm doing a two-string function to this, and I'm able to see that each one of these counties is just a polygon in my table. So being able to store these shapes helps to bring the power of visualization. So if I have data, for example, maybe I have voting data in a table. If I can relate this to these shapes, then I have the capability of bringing some powerful visualizations to my data. So then, if I have voting data, I could get, fancy in some reports and do some of those like CNN kind of things where I can show how the different counties are voting. So any of the data, any data you have, you might have the potential to bring some powerful visualizations to that using spatial data. So I want to make sure I have plenty of time for everything, so I'm going to skip that other example. And here I'm going to run this query. and this is going to help us see some of these methods or functions that we can do on this. So if I go to the spatial results, this is our example, the oil spill in the river. So with these functions, I can do some really cool things like, okay, this oil spill has happened. Let me take a look at the entire river and where it's impacted in this. So, I could do something like that. So the ST union is giving me both of those shapes together as they exist. Then if you see here, you can see the difference. So, for example, this is I could use this quickly to give me information on my river. What parts of the river are not impacted, so I can get a statement. I can query the database and get a statement out, figure out what areas are impacted to tell fishermen they can still fish in these areas, or something to that effect. If I do the ST intersection, it's a little hard to visualize, but this is actually the river that runs through that square, so our area of oil spill. So this would actually give us really quickly the area of the river that was impacted by the oil spill, and just that. So very cool stuff. So we've seen some geometry data types, so I wanted to do one as well for the geography data type. So I'm going to run this query. What I have here is a couple points, and in the geography data type, typically a point is going to be the latitude and longitude. So again, this is my favorite local brewery, and I have this is the latitude and longitude. One thing to note, this is actually the latitude and this is the longitude for the brewery. It's a little confusing because it's a little backwards from the typical reference of latitudes and longitude together. The reason that it's longitude first is because the longitude is going to give you the information as it exists on the x-axis. So again, it's xy. So that's the reason for that. The longitude is the distance from the prime meridian. So that runs along your x-axis. So that's the reason why you do longitude first. And then the latitude is giving you distance from the equator. So just something to note.
Hope, what is that distance measured in?
Excellent question. So I picked a spot downtown, Monument Circle for anybody who's familiar with Indy. And then I'm doing the ST distance. This is giving us, and it brings up another point I want to make sure to mention. This is actually giving us the distance in meters. So, and it's also the distance as the crow flies, so a straight line. So, driving and roads aren't taken into account, but it's giving you the actual distance from it. So, in spatial data, there also is something called a spatial reference ID. The spatial reference ID, the default for the geography data type is 4326. So, that is giving you, I'm sorry, I heard something downstairs and it caught me off track. The default for the geography data type is 4326, and that is, so I don't specify this up here, so that it is using the default, and that is in meters. I will show real quickly, there are many different spatial reference IDs. I just queried the system table, and there are 391 rows returned. There are different cultural differences and different units of measure for these, but it's basically the rules system that you're going to abide by for your spatial data. And you can see, like, Hong Kong 1963 uses Clark's feet to measure their distances. There are also differences, different places think the curvature of the Earth is a certain amount. Some think it's others. So various different rules that regulate your spatial data. Okay. let's move on and show you some other ones real quick. Let's see here. We will run this one. Make sure to show you one of these fancy new curves that you can have in spatial data sense. So what I did here was, this is a compound curve and it can be empty. Let's move down so we can see this one. So, stretching my artistic skills here, this is, let me bring this up here. Oh, that really changes the screen. So the circular string, what a compound curve is actually, it is a collection of multiple different objects. And so this one is a compound curve, so it's a collection, and the first one is a circular string. Like I said, you start with the start point, and then it tells you, that second point tells you how far to curve your line, and then your end point. So then it comes over here like this. Let me escape that so you can see. Then if we move over, you can see then it's kind of that dot-to-dot system. So it ends at -1, 0, and then it has -0, 1. What I've also done is I've done this function, ST is valid. So like I said, it's a dot-to-dot system. So in my results tab, you can see here I have 1 come back from the ST valid. So it's saying, yes, these shapes are valid. But so if you're like importing data, you can potentially run an ST is valid on these and validate that data as it comes in. So let's change this one here, and I'm going to run this, and it's going to give me a funky error. So you can see here we got a .NET error come back, and it freaks out. If we go to the results, you can see it no longer returns the 1 because the start and end points aren't valid. But if we do that, all is well with the world again. And we can go back and we can see this one here. So this is that shape, which I was trying to get a little fancy, but it looks kind of like one of the symbols on a Led Zeppelin album. But so that one, I wanted to do a query for you guys to show you one more, another function, which we're going to do shortest line to. And if you see my comments here, this might be the geekiest query of all time. It's up for judgment, but here, let's go ahead and run this. So we have some stuff come back. Let's go to our spatial results. So our first shape here, you can see, I'll pull this up here. So we have a curved polygon, doing some circular strings here. And if you go down, here's another shape. Now, hopefully my artistic skills are good enough to where you can tell what this is. What I've done here is, so this is doing the function shortest line to, I've put a buffer on it. ST buffer, what that means is fatten the line up just a little bit, or fatten up whatever shape it is, just a little bit so we can see it. So we now have shortest line to showing us the shortest line between these two particular shapes. I also put a toString on this, so then we can get back the coordinates or the line string coordinates for that particular shape. So yeah, so that might be, it's not too often you can try and recreate a Star Wars movie scene in Management Studio. So so now we've done that. I'm going to go back to the slides really fast to set up the main demo portion, our real world demo. So for this example, we're going to pretend that I have a hotel. I have a hotel and Plaza del Hope. So as the proprietor of this hotel, I have in my possession a CAD file. What a CAD file is a computer animated drawing. Typically, larger pretty much any commercial construction uh, job is going to use a CAD file of some kind to be the blueprints for building the building. It has all kinds of information on it. So I have, okay, so when they built the hotel, I have access to the CAD file for my hotel. And then I just have normal run-of-the-mill hotel data in a SQL Server database. Get, hotel guests, room information, room blocks, customer complaints, that just normal data stuff inside my SQL Server. I did do some prep work, and I'll mention that here. So after I had that CAD file, what I did was get it into the format of a shape file. Shape files have been around for a long time. They're basically files that contain all of the information, all the mapping information that would be used to put the data inside of the SQL Server spatial data type. What I used was the Esri people have been doing mapping for a long time. They have an ArcGIS for desktop application. I used that to get my CAD file into a shape file. If you're familiar with this application, there is the ability to go directly from CAD file to a SQL Server database, but I unfortunately didn't have the version that would allow me to do that. So, but I knew I could get it in, if I could get it into a shape file, I could get it into SQL Server. So I did that conversion. Then I used a utility from an open source library of tools called OGR to OGR. And I have some information. Alistair Atchison did a really great blog post on helping give you the information to do that. Underneath there you can see the syntax of it. It's just a command line utility where I use that to get my shape file imported into SQL Server. So okay, after I had my data into SQL Server, I just created a relationship from the spatial data to the room number. So a little bit of the setup. The CAD file I was able to acquire for this was, if you're familiar with Indianapolis, there's a nice newer hotel called the JW Marriott. Over on the left is a picture of the hotel. Over on the right, if you haven't seen CAD files, this is a view of the CAD file that I used. So it's the layout of the hotel, one floor of the hotel, but you can see that's what it looks like. So now that we have all of that, let's jump out again and play with this. So I'm going to go here. I'm going to show you a couple queries real fast. So after I imported my shape file into the into SQL Server, this top one here, this top results is what comes back. You can see it's giving me, oh, there's too many, I'm doing a select star, but you can see here, and there's the ability to zoom, so I'll zoom in on this, move this up a little bit. You can see here it brings a lot. Each one of these different colors is a different shape, so even CAD files typically have even more information than what you see here, pipes and the different layers. A lot of that was taken out. I just really wanted the outline of it. So so what I did was, you can see back in the results, I went and I had a table with the rooms of my hotel, and I correlated that, created the relationship to the different shapes that it is actually in my hotel. So if we run this query, this is what we want to see. So let me zoom a little bit here. So now I have the floor plan and the layout of my hotel inside of SQL Server to do with as I wish. So very cool, huh? You can see I can pull back my room numbers. But now I have the floor plan, and I can do a lot with this. So I'm going to jump out, and I'm going to start up report builder. Good old report builder. I'm going to do a map wizard. You can see here this I could use shape files as layers in reporting services or in report builder. I'm not going to do that. I'm going to do spatial data query. So let's say next. We're going to do a new data set. We are going to do a new data source. I'll say hotel data. It's just on my local host. I'm going to grab my database. I'm going to test it and say OK. Okay, so we have our data source. I'm going to edit as text, and so I don't waste time trying to type these out for you guys, I'm going to grab this query here and paste it into my... Okay, so all I have is the room number and the shape. Great, we'll say next. So this is the same thing we saw before. So this is just the layout. This first one is just the layout of my hotel and my hotel rooms. I'm going to say next. We'll do basic map. I'm going to choose generic single color and say finish. Nice. Okay. So nice. We have that. That's nice. We'll call this Plaza del. No, del. Oh. And we'll give it a title. Hotel guest lock report. Okay. We have our first layer. I'm going to go over here now. See if I can move this down so you guys can see that better with the resolution. Okay, so we'll say we're going to create another layer. Another spatial query. Add that, point it to the same data, edit as text. Let's go grab the next query over here. Okay, and you can see here we have a parameter, a date parameter, so I'm going to run this and it's going to ask me, what do you want that to be? We'll just put 414-2014, give it a date. So okay, very nice. So now we're getting some customer information. We have our room number, we have our shape, and we have some interesting hotel guests. It's my hotel, my demo, I can pick whoever I want to stay at my hotel. So Hugh Jackman is staying with us. We can see the arrival date and the departure date. All right, we have some interesting hotel guests. Nice. I'm going to say next. It's going to kind of freak out on me for a minute. It's like, the parameter doesn't pass through to this view, so then it gives me this, and it's going to give me it looks like a cluster of countries that I'm not familiar with, but that's fine. We'll say next. It's just that parameter that throws off that view. We're going to say basic map again, generic single color, and finish. Now that looks not so nice, but don't worry, it will be fine. I'm going to go ahead and change my parameter properties. I'm going to do the prompt to say date. I'm going to say date time for the type. Let's specify a default value, so it's 414-2014. Say OK. I'm also going to go over here. I'm going to do polygon properties. I'm going to change the fill type because white on white would be difficult to distinguish. So we'll say OK. Let's run this. And it's loading. So nice. So really quickly, I'm able to now see this is where my hotel guests are staying in the room. So I get this quick visual of the rooms that are booked for this particular date. And if we change the date to the 15th, let's view the report. Excellent. We have, we're fully booked on the 15th. That's super awesome. And this is where I start doing kind of the infomercial host, but wait, there's more kind of thing. I'm going to go back to design, but wait, there's more. And let's do another layer here. do another spatial data query. We're doing a new data set again. We're pointing it to the same data. I'm going to edit as text. Let's go grab the next query. Grab this, copy, paste. This again has a parameter, so it's going to ask me for it. 2014. So now we can see, okay, we have room number, we have the shape, we also have, nice, Dwayne Johnson, this CONV field. What that is the room blocks. So anytime any group calls and they need a block of rooms, this is the field that's going to be filled in with whatever particular makes sense for this. So we have the SQL Saturday group and the youth hockey team. That's nice. These guys, both of these guys, I remember these guys. They're a little bit loud. Youth hockey teams, they're playing hockey in the hallways. They're annoying and loud. So we'll say next here. It again can't understand what's going on. Gives me the block of countries there. I'm going to say next. This one we're going to do as a color analytic map. I'm going to say next. This is the data set. I'm going to change this to CONV, which is the field that represents our room blocks, and that's fine. We'll leave it yellow, red, green, yellow, red. That's fine. All right, so very nice. Let's run this. First, I'm going to get rid of this guy. I'm going to move this guy over here so it doesn't get in the way of the view of our report. Okay, nice. This is nice too. This is great. So now I'm able to see, okay, I have these particular room guests, and then I can visualize who is with room blocks or has a block of rooms at our hotel. But wait, there's more. Let's go back. I'm going to do another data set. I'm just going to right click and do data set. I'm going to call this one complaints. Complaints, making sure to spell it correctly. I'm going to embed it in my report. It's also going to point to the hotel data. I'm going to go grab this here. Start here, grab you. Okay, so I'm going to pass it this. I'm going to say OK. All right, that's nice. I'm going to click on here and bring up my layers again. I'm going to get this second layer, which is the one where it just has our hotel guests. I'm going to go grab what I need here. Definitely don't want to type this out. Grab this. I'm going to right click and go to Polygon Properties. I'm going to create a tooltip here. So I'm going to use this as my tooltip. I'm going to say OK and click OK. Now let's run this again. And I'm going to hover. Nice. This is giving me, now I can see which hotel guest. If I hover over this, I can see which hotel guest. David Beckham is staying with us. But it also it's pulling against a complaints table. So Joffrey Baratheon, when I was creating this demo data, I was going through a very Game of Thrones period. So, and we have Cersei Lannister. Joffrey Baratheon and Cersei both have a history of complaints. She's complained a bit, but I have her next to the youth hockey team. This could be a problem upcoming. But having this ability to now, quickly visualize this, I can potentially, she's going to be staying with us. I might want to move her. Let's see here. Let's change to the date. She's going to be here for a couple days. We have the knitting club and the mime convention staying, also having room blocks with us at Plaza del Hope on the 15th. It might make sense to swap her out. So Sam Elliott, I might want to switch Cersei and Sam so she can be next to the knitting club. But you can see that it gives us some powerful capabilities, being able to quickly visualize our data. and see where we might be able to save ourselves some trouble before we have them, keep the customers happy, keep our hotel guests from complaining. Life is good, all's well with the world, just because we use spatial data and tied it together with our SQL Server. So I'm running out of time. So now that we've seen that, that's about it for me. So I will go ahead and here are the resources. I would love feedback on. I want to make everything better. So please give me some feedback. Here is my information: email, Twitter, blog. Andrea, I think I need to pass it over to you. Yes, definitely.
Great. Before questions, I want the room next to Alexander Skarsgård, if you can arrange that.
Yeah.
So, are these functions only in SQL 2014? At the very beginning, you were showing some functions.
Some of them are, some of them aren't. The shortest distance, one of the ones I did where I did the Star Wars thing was a 2012 function. Many of it, like the ST buffer, has been around since 2008. So some of those are, that is an excellent point. Excellent question. There were functions from the get-go in 2008, and they've kind of added most of the advancements in the spatial data came really with the 2008 R2, and then 2012. Unfortunately, they kind of set those aside for 2014, and I have not heard of many advancements for it. But yes, the functions have been around for as long as and they've added to them as they've went along. So excellent question.
Can you go back to your contact slide and put that up again?
Yes.
And we also have a request for the resources slide too. So just
yes. Yeah, I'll go here for a minute. I will definitely make these available to anybody, so you don't have to get these down necessarily. But yeah, feel free. I can get these. I'm sure they'll be up on the PASS site as well. So.
Okay. Are there functions that classify how similar or different shapes are between and among each other?
Can you repeat that again?
Yeah. Are there functions that classify how similar or different shapes are between and among each other? So I wonder if it's kind of like overlaying shapes or something.
Yeah, I mean like we saw, there is a function that shows when they overlay each other in area. I will have to I'm not aware of any function that says how similar they are to each other. There are many, like you can do st area to see if they are similar in area, but as far as like being exactly the same, how close they are, I'm not aware of any, but I can't promise you that, but I will definitely look into that. So.
Okay, great. And then we did have a question that came up. We kind of answered it about what can you display your data in? What would you recommend? You showed Report Builder. What are some other softwares that you would use?
Yeah, so as far as SQL Server goes and the Microsoft products, you're going to be limited right now to reporting services. Reporting services can do spatial data very well. Like I mentioned before, the Power tools, all of the Power View and Power Map, they do not support spatial data. I'm hoping they change that soon, and they're on the faster release of with upgrades to those products. But as of yet, you can't do spatial data. But like if you have like if you're doing I always would tell people, if you have an address table of any kind in your SQL Server, you can do spatial data with that. You can do points of latitude and longitude. The Power Map and Power View will allow you to do latitude and longitude but they don't do spatial data, which stinks because some of this stuff, like I picture like trucks saving truck routes and those kinds of things. If the data needs to persist, then you're limited in those reporting capabilities, and you need to store that in SQL Server in the spatial data. So I'm hoping that will change. So
Wonderful. People are requesting the resource slide again.
oh yes, I'm sorry.
You've done fantastic. Do we have any other questions that need to be answered? I'm watching through the question pane.
Okay. We got time left. I got something I can show. I wanted to make sure I had some.
Let's do it. Let's go for it.
Okay. I know when I first started seeing spatial data and I started playing with these queries, and like I showed the geekiest query of all time, doing stuff like this, having a little fun with it. I was picturing like the ASCII art stuff. You'd scroll through your email and it would create with the different characters a shape or what have you. One of my friends, Michael J. Swart, he also has done something with spatial data, and I want to show you guys real quick. I wanted to make sure I had time for the demo, so I'm going to run this, and in the resource slides I referenced this. I pictured people just going crazy with doing these, and this was one of the funnest examples I have seen of spatial data. So you can see here he's taken spatial data to this is just awesome. So and I have a reference to the blog where you can actually go get this query, but he did some C# magic to help him plot these things out. But you can plot and play, plotting different things out on a grid. I've seen people do like Christmas cards. I remember somebody sent out a query as a Christmas card, and it created a Christmas tree for you. So I thought that was a super fun thing that he did, and I just love it. So he said I could. He said he gave me the okay to show you guys this. So.
Very cool. We had another question come in. Has spatial data changed much in 2014?
I have not seen anything. I haven't seen anything, and I hope to find out. Well, I have not seen anything as far as any new features in spatial data in 2014, unfortunately. So sad to say. Sad to say.
Okay, great. Your geekiest query ever is, I heart that.
Yeah, yeah. It was fun. Yeah, it was fun. Yeah. So, but I think thank you everyone for attending today. I appreciate your time, and I thank you all so much. If you have any feedback, I would really appreciate it. Let me pull up those slides again. So, those slides. I'm sorry, go ahead.
Sorry, I was going to say, if you like what you've heard here, Hope will be presenting at Past Summit 2014, so catch her in her full presentation of this session, which is Spatial Data Looking Outside the Map at Past Summit 2014. Don't forget to use the discount code 24HOP14 to save $200 on your registration. And then next we have coming up Gail Shaw with Guessing Game Statistics, Heuristics, and Row Estimations. That's happening in a couple of minutes. Did you have anything else, Hope?
No. Thank you all. Thank you, Andrea. Thank you, Pat.
Thanks, everyone.
Thank you, everyone.